Hello, we are the Metal Maestros, and this is Logan Burke from the University of Alabama here to do a voiceover to describe our process and some of our design choices for the SFSA Cast in Steel 2023 African Spear Point competition. We started with a 3D print. It is printed in PLA. We found that for the investment casting process, it performs the best during the burnout process. This picture is us confirming the fit up on a broom handle. Very accurate. From there, we moved into the wax room where we're able to fit the gating system and the venting system to the 3D print. All of the wax here is cored to prevent cracking of the ceramic shell due to expansion when it's put into the burnout furnace. We took a 3D scan of the whole piece using the iPhone's LiDAR camera. This just gives us some dimensional information for later when we go to put this into magma. Next, we started to build up that ceramic shell that I mentioned. Typically for steel, we recommend 8 to 10 coats of the suspenda slurry and the silica sand. It's the most time consuming part of the project since each coat has about a 24-hour drying time associated with them. After this shell comes out of the burnout furnace, we can see Colin here doing some patchwork on the shell. This is a different spear, but it lets you see our fluidized bed that we use to bury the ceramic shells after they've been preheated and prepped for pouring. This is a previous pour of 1080 steel. It just shows some of the drawbacks of using suspended slurry with 3D prints. It's possible for the slurry to invade the support structure of the print, causing inclusions of ceramic in the actual cast geometry, which you can see here. For this project, we wanted to try to make a soft backed blade. So for that, we chose a relatively soft 304 stainless for the bulk of the spear, and then we welded a piece of very hard 8160 steel on the edge. By having the edge but intentionally having a soft 304 stainless steel bulk, we can provide high toughness without sacrificing on any edge performance. And here's our final product. Colin added some leather work to the handle to really bring the whole thing together. This project really made us test our skills, and in the end, we delivered a spear that me and Colin were both proud of. I'll leave you with a time lapse of our pour day at the University of Alabama Foundry, and thank you.